you're asked to differentiate and simplify the following function. Now, as you can see, this is a function of a function of a function. It's a composite function, but there are three functions, all right? Making it a little more complicated than when you are dealing with two functions, one being a function of the other. Here, x squared plus 10 is a function. ln of x squared plus 10, ln of that is another function. And then sine of all of that is yet another function. Now, you will need to use the chain rule to do this. You're going to use differentiation by substitution. But you will not just make one substitution, there will be two substitutions. So what I want you to do now is to pause the video, write the question down, and try it. Okay, so you finished? What did you get? Let's look at what's going on here. Let's change this from f of x. Let's say it is y equals sine of ln of x squared plus 10. Okay? Now you have this inside function. Let's call it u. So we substitute. Let u be equal to x squared plus 10. Let me move the 10 a bit here. X squared plus 10. So what we have then is y is equal to the sine of ln u. See that? We have the sine of ln u. After that, remember, we have yet a function of that function. So ln of u itself is a function, right? This ln u is itself a function. So let's make our second substitution. Call it v. Let v be equal to ln u. So what we have is y is equal to sine v. You see that? Now, how do we set up our dy by dx? Chain rule. The derivative of y with respect to x, dy by dx is equal to, here you can say that we have dy by dv. You can differentiate to find the derivative of y with respect to v. So we say dy by dv times, I'm going to put that for multiplication, right, times, we have v is equal to something u, so we can times that by dv by du, and notice the dv can cancel the dv, you have dy by du, but we need to go a little further, times, right, now we have u is equal to something with x, so this is the u, you can find the u by dx, so this is the u by dx, and we have them all now. Look at this, if you make dv cancel dv, du cancel du, what you get is dy by dx. Alright? So, let us find them separately now. What is dy by dv? Well, y is equal to sine v. And from the table of derivatives, which you should remember some of the values, the derivative of sine is cos. So this is cos v times what is dv by du. We have v is equal to ln u. Now, you should remember that if you have something like y is equal to ln x, then dy by dx would be 1 over x, right? You remember that? Now in this case, it's u we're dealing with. V and u. So if v is equal to ln u, then dv by du would be 1 over u. And then multiplied by du by dx. U is equal to x squared plus 10. So you use the power rule now. You're going to have in the power rule 2 times x to the power of 2 minus 1. Remember, you multiply the power and reduce the old power by 1 to get the new power. So it's going to be 2x. The 10 is a constant, so it will be 0. So it's 2x. You see that? Now the thing is, what did we say u was and v was? Because you need to change them back. Alright? Oh, my mistake. It should be dy by dx, not dy by dv. Oh my. Yeah. You need to change the v and u back to x, because remember, the function we were given is a function of y and x. So we need to have only y and x now, as well as some numbers. So v was what? V was ln u. So this is cos ln u. Right? Times 1 over u. What was u? U was x squared plus 1. Now plus 10. X squared plus 10. So this is 1 over x squared plus 10 times 2x. Nothing to change in that last part. Now, we still have a u. So we can say that all of this is the cosine of ln u, which is x squared plus 10. You see that? Times 1 over x squared plus 10 times 2x. Alright? And of course, we could just write the 2x over. So just put the 2x up here. So it's 2x. So it's cos of ln x squared plus 10 times 2x over x squared plus 10.